Good morning. Hello and welcome once again in the lecture series on course Elements of Machine Design. Myself, Mr. S.S. Manik, Head of the Department Mechanical Engineering, Sharath Institute of Technology Polytechnic, ETRA. Up to this lecture, we have seen what is meant by machine design. We have gone through the syllabus of machine design. In second lecture, we have seen what is the major considerations in designing any machine element. In lecture number 3, we have studied what is the basic design procedure of any machine element. Now, in this lecture, we will study about the basics of stress, strain, and different types of stresses. So once again, I welcome you. Let's start with what is meant by stress. First of all, actually going into the definition of stress, let's have a look on what are the major causes due to which stress induces in the machine component. Now, in engineering practice, the machine parts are subjected to various types of loads, as we know, which may be due to the either of the one of the following. That means the machine part is going to subjected different types of loads. The causes due to which the load acts on the machine part is one of the following. The first cause is the energy transmitted. As we have studied in the definition of machine, that machine is a device which actually take input in the form of energy and it transfers that energy to the another element. That means it is an energy transmission element, energy transmission device. So this is the basic task, that is the transmission of energy. And when this energy is transmitted through the different mechanisms. So this is the first parameter which enables the transmission of energy, which enables the induction of or subjection of different types of the forces on the machine element. The second element is the weight of the machine. Self-weight of the machine is also a responsible factor due to which there is an induction of simple stresses in a machine part. Third parameter is the frictional resistance. As we know that when two parts are in contact with each other, when they move with respect to each other, then there is a possibility of frictional resistance between these two parts. That frictional resistance causes the subjection of loads or induction of stress in that element or part. The next part is the inertia of reciprocating parts. As we know that inertia is nothing but it is the velocity gained by that element or particle due to its motion. We know that moment of inertia. Inertia is the basic motion which is imparted to the reciprocating parts. When that parts move with each other or reciprocates with respect to each other, then there is a possibility of the induction of the stresses in the machine part. Next parameter is the change of temperature. As we know that different machine elements or parts are subjected to different kinds of atmosphere. That means machine has to work in different kinds of atmosphere which is subjected to different temperatures. And when there is a change in the temperature, there is an induction of stress in the machine part that we know as the thermal stress, which is induced in the machine part due to the change in the temperature or the temperatures to which the machine part or element is subjected. The next parameter is the lack of balance of moving parts. In many mechanisms or in many cases, that structure is subjected to the vibration. The main cause of the vibration is the lack of balance of moving parts. That is the main possible reason why the stresses are induced in the machine component. These different forces acting on machine part produces various types of stresses. These are the parameters which are responsible for the action of different types of the loads on a machine part. Due to the application of these loads, there is a induction of stress in the machine component. That means the machine component is subjected to different types of the stresses. So before going into the actually types of the stresses, let's see what is meant by the load. In previous slide we have seen what are the different parameters which actually cause the load on a machine part. In this slide we will see what are the different types of the loads that acts on the machine element or machine parts during the process or during the mechanism or during the working of that machine element. First is the dead or steady load. The first type of the load is the dead or steady load. What is meant by the dead load? A load is said to be a dead or steady when it does not change in magnitude or direction. If a constant load is acting on a machine element or machine part or any structure, then we can say it is a dead load. Take the simple example of a dead load. If the machine is erected on some platform and if there is no mechanism in the machine, then that kind of a load is considered as the dead load. A simple load, if we keep some device on a something platform, then the load acting on that platform will be a dead load. That is the steady load, which do not change in magnitude as well as the direction. The opposite to that is the live or variable load. A load is said to be live or variable when it changes continuously. Simple, take the example of our two-wheeler. When a single person is riding a automobile, a vehicle, then the load acting on that vehicle gets changed due to the position of the road, due to the obstacles in the road, but due to the nature of the road, there is a change in the load of the shock absorbers. So this is a live load, the simple example. Third is the suddenly applied or shock loads. The load is said to be suddenly applied or shock load when it is suddenly applied or removed. Simple. If you hammer something, if you hammer a nail, then it is a shock load or suddenly applied load, or there is a bump due to some conditions, then it is a suddenly applied. When the door moves due to the wind speed, then it is a suddenly applied load which acts on the machine element. And last nature of the load is the impact load. The load said to be an impact load when it is applied with some initial velocity. Take as an example of a hammer. When we apply a load by a hammer, when we nail something, then we are applying that hammer with some velocity. That is the impact load. Take the load of a forging machine. When it press in a press machine, when that press something, the load is applied with certain velocity. That is the impact loads. So these are the some basic types of the loads which are acting on a machine element. That is the dead load, live load, suddenly applied loads, and impact loads. So these are the loads which actually are responsible for the induction of stresses in a machine element. Now let's move towards the stress. Now in this slide we will understand what is the concept of stress. What is meant by the stress? Keep in mind, you should not get confused with the concept of load and stress. Let's go through the definition of the stress. What is meant by the stress? When some external system of forces or loads, when some loads or external system of forces or loads act on a body the internal force equal and opposite to the applied force. When some external system of forces or loads act on a body, the internal forces, or we can say a resistance, the internal resistance offered by the body to this applied force, that internal resistance is equal and opposite. This internal resistance is the equal and opposite. This is the equal and opposite. That is most important part. This is the internal resistance offered by the body, which is equal and opposite, are set up at various sections of the body which resist, that is the most important part, which resist the external forces. This internal force per unit area, or what we can say, this internal resistance per unit area at any section of the body is known as the unit stress, or we can simply say a stress. Means if we apply some external system of forces or loads on a body, then this body itself offers the resistance which is equal and opposite to this external force. This internal resistance or this internal force which is offered by the body to this external load per unit area at any section. You can't take some section. This resistance is offered throughout the section of the body. Yes, at any section, that resistance which is offered by the body is known as the stress. It is denoted by a Greek letter sigma. So this is the concept of the stress. It is the internal resistance. It is the internal opposition which is offered by the body to the external load, external force at any section. That is the concept of stress. In simple language, when we say load is applied, always keep in mind load is applied on the body, but stress is induced in a body. Stress is an internal phenomena, load is an external phenomena. We are applying load on the body, we are not applying the stress on a body. Keep in mind, when we apply load on a body, then there is a possibility of induction of stress within the body. That's why always stress always get induced in a body, it is not get applied. Keep in mind. So this is the definition of the stress. Mathematically we can write stress as a force per unit area. As we have seen in the definition, we can write a stress as a force per unit area. This is the force per unit area, where force is the applied force acting on a body, and this is the cross sectional area. Always keep in mind cross sectional area. This is the most important part. This is the cross sectional area of the body which is actually offering the resistance to the applied force. The SI unit of stress is the Pascal. It is the, in general, the stress is expressed in Pascal, and we have a relationship 1 Pascal is equal to 1 Newton per meter square. Keep in mind, it is required at the time of the solving the problems. This is most important relationship. Many times the students get confused with the convergence. That's why the students feel that the problems are difficult. You always keep in mind convergence are very important. The basic unit of stress, that is the SI unit of stress, is the Pascal, and its relationship is 1 Pascal is equal to 1 Newton per square. And another unit, that is the, when we want to express a stress in bigger units, then 1 megapascal, 1 MPa or 1 gigapascal. Its relationship is 1 megapascal is equal to 1 into 10 raised to 6 Newton per meter square, that is 1 Newton per square. Keep in always mind, 1 megapascal is equal to 1 Newton per square, and 1 Pascal is equal to 1 Newton per meter square. This is the most important relationships. 1 Pascal is equal to 1 Newton per meter square, and 1 megapascal is equal to 1 into 10 raised to 6 Newton per meter square. These are required at the time of the solving the problems. So once again, what we understood by the stress is nothing but it is the internal resistance or internal opposition which is offered by the body to the applied external load. It is the per unit area. In that area is the cross-sectional area. So this is the basic concept of stress. The pressure is different and stress is different. The pressure is applied on the body, but stress is induced in the body. Keep in mind. Our next concept is the strain. What is meant by the strain? As we have seen in previous slide, when we apply the force on the body, there is an induction of the internal resistance per unit area, and that we known as the stress. But due to the application of load, another thing happen in the body, that is there is a deformation. When a system of forces or loads acts on a body, it undergoes some deformation. Deformation means change in dimensions. That is the meaning of the deformation. As we have seen, when we apply the force, there is induction of the stress, but at the same time, when we apply some load or a force on a body, the body undergoes deformation. That means its dimensions get changed. That is known as the concept of strain. This deformation per unit length, is known as the simply strain. That is, when a force is applied, there is a change in the dimensions of the body. It is denoted by a Greek letter epsilon. As stress is mentioned by the Greek letter sigma, in the same way the strain is expressed by a Greek letter epsilon. Mathematically, this strain is equal to change in length to the original length of the body. That is, when we apply the force, there is a deformation, means change in length to the original length of the body is known as the strain. And strain do not have unit because it is the ratio of same dimensions. Strain do not have unit because the strain is a ratio of same dimension. Change in length we can express in meter, original length we can express in meter. So this meter get cancelled. That's why the strain do not have any kind of a dimension. Now this is the concept of strain. So we have seen the concept of stress, we have seen the concept of loads, we have seen the concept of stress. Now let's move towards the types of stresses. Means due to the application of applied force on the body, there is induction of stress that we have seen in last slide. Now let's move towards the what are the types of the stresses which are induced in a body due to the application of a load. Now just go through the basic stresses, that is the direct stresses. We can say direct stress means these stresses get induced due to the application of the direct loads, that is the tensile load and compressive load. Now let's move to the tensile stress and tensile strain. Now when a body is subjected to two equal and opposite axial pulls, this is one axial pull and this is another axial pull. Now consider this as a member. This is simply a member, or this is simply a part to which we are applying two axial pull. It is also known as the tensile pull. It is also known as the tensile load because the direction of force is away from center of the body. This is the center of the body, away from center of the body. That means we are pulling. These are known as the pull force. We are pulling the body by application of two equal and opposite axial pulls, also called tensile load, as shown in diagram. Then the stress induced at any section. Now when we are applying these tensile pulls on the body, there is a possibility of breaking this body at this axis. This is the axis of the body. There is a possibility of breaking of this member at this point. That is the breakup. This is the breakup at this point. And here this is the internal force, which is resistance offered by the body to the application of this tensile loads. And as we have seen, the stress is nothing but it is the resistance offered by the body to the applied load. So this is the resistance, this is the section, this is the cross sectional, this is the cross section. So this is the front view of the body. If we go to the side view, then you can say this is the cross section of the body. Now when we take side view of this section, then we will see like this. It is the circular section. So suppose this is a shaft, a circular member, and when we apply this tensile load on the body, then there is a possibility of the breaking of the body at the middle of the section. And this resistance offered to the breaking means that body does not want to break. This resistance offered by the body to the breaking due to the application of tensile pull is known as then the stress induced at any section of the body is known as the tensile stress. In simple language, when we apply a tensile load on a body, and if the body is offering some resistance, now this is the resistance means nothing but the equal and opposite force. The direction of this force is opposite to this, but the magnitude is equal. This opposition offered by the body, this opposition will be offered by this cross section. That's why this is the cross sectional area. This opposition will be offered by this cross sectional. That's why it is known as the tensile stress. A little consideration will show that due to the tensile load, there will be a decrease in cross sectional area when we apply this force. See, there is a decrease in cross sectional area and increase in length of the body, and there is an increase in length of the body due to the application of this tensile load. So this is tensile stress, that is the resistance offered by the body to this tensile load is known as the tensile stress, and there is a change in length of the body, means this is the original length of the body, and there is a change in the length of the body due to the application of load, that is the increase in length of the body and decrease in cross sectional area. This is the axial tensile force acting on the body. Area is the cross sectional area of the body, which is circular. So mathematically we can express tensile stress, mathematically we can express the tensile stress as a tensile force divided by cross sectional area. This is the cross sectional area. Axial tensile force acting on the body divided by cross sectional area of the body, and this cross sectional area is the circular cross sectional area. Now this is the concept of tensile stress. Now move towards the tensile strain. As we have seen, due to the application of pull force, that is tensile load, this is the original length of the body. Yeah, but due to the tensile load application, there is a slight increase in length of the body. This is the original length, and delta L is the increment in the length of the body, and there is a decrease in cross section of the body. Look at this. This is the original shape of the body. It is the front view, that's why it looks like a rectangle, but it is a circular. And this is the decrease in area at the midest section of the body due to the application of this tensile load. There is a decrease in area, but there is a increase in length. But how much length is increased? It is increased by delta L. So total length will be L plus delta L after application of force. This is the length before application of tensile load, and after application of the tensile load, the length will be L plus delta L. That is the final length of the body. So original length of the body L, and increasing length of the body is the delta L. So strain, as we have defined in the previous section, strain is nothing but the change in dimension to the original dimension. How much there is a change in dimension? Delta L, and original dimension is the L. A little consideration will show that due to the tensile load, there will be a decrease in cross sectional area and increase in the length of the body. The ratio of increase in length of the body, that is the delta L, to the original length is known as the tensile strength. And it is the indication of tensile strength. Epsilon suffix small t for tensile. This is the tensile strength. So we have seen the concept of tensile stress and tensile strength. Now let's move towards the compressive stress and compressive strength. Now in previous slide, we have seen how tensile stress get induced in the body. Now in this section we will see what is meant by the compressive stress and compressive strength. Compressive means pushing. This is the push force. Consider this is the member. This is the circular member. This is the cross-sectional area, side view of that member. That is a circle. Now in previous section we have seen tensile load, but this is the push load. Push means towards the axis of the element. When a body is subjected to two equal and opposite axial pushes, also known as the compressive load, then the stress induced at any section of the body is known as the compressive stress. Now this is the compressive load, this is the compressive load. Due to the action of this compressive load, there is a deformation of the body. There will be a deformation of the body, but this deformation will be resisted by this equal and opposite. This is the application of force, and this is the equal and opposite axial push. This is an equal and opposite. It is the resistance offered by the body. This section is the resistance offered by the body. This section, this is the resistance offered by the body to the applied compressive load, and the direction of load is opposite to applied load, and magnitude is same. So this is known as the compressive stress. That is the resistance offered by the body due to the application of compressive load. In case of tensile stress, it is the resistance of the offered by the body due to the application of tensile load per unit area. That is the only difference. That is the nature of load. If tensile load is applied, then tensile stress will get induced. If compressive load is applied, then compressive stress will get induced. So this is the concept of compressive stress. It is given as compressive stress is equal to axial compressive force divided by cross-sectional area. That is the compressive stress. Letter is sigma, suffix is C for compressive. And compressive strength. Now in previous slide we have seen, due to the application of tensile load, there is an increase in length. Because the load is acting away from the body, we are pulling the body. That's why there is an increase in the length but decrease in cross section. But in case of compressive loading, exactly opposite is there. Look at this. We are actually pushing the body, means we are applying the push force on the body. We are applying the push force on the body, and due to the applying the push force, there is increase in area of the body. There is an increase in the area of the body, but there is a decrease in length. This is the original length. This is the original length, but due to the application of force, there is a decrease in length by dl. Now the body, due to this deformation, there is deformation of body through this distance. Now this is the final length of the body after application of this compressive force. So how much decrease in the length? Delta L. Means final length is L minus delta L. Original length was L. Final length will be L minus delta L. So according to definition of the strain, the strain is defined as the change in length. How much change in length? Decrease, as there is a decrease in length. In case of tensile loading, there is increase in length, but in case of compressive loading, there is a decrease in length. How much decrease? Delta L. And what was the original length? L. So according to definition of the strain, what is the basic definition of the strain? Change in dimension to the original dimension. Now change in dimension is the decrease in length. How much? Delta L, and original dimension was L. So this is the compressive strain. That is decrease in length to the original length. And what is the compressive stress? Compressive load. That is the external load acting on the body to the cross-sectional area per unit body. So a little consideration will show that due to the compressive load, there will be an increase in cross-sectional area and a decrease in length of the body. So the ratio of decrease in length decrease in length to the original length is known as the compressive strain. So in this lecture we have seen what is meant by the load, what are the different types of the load, what is meant by the stress, what are the responsible parameters that actually responsible for the application of load on a body when it subjected to the application, what is meant by the definition of stress, what is meant by the concept of stress, what is meant by the concept of strain, what are the different types of stresses. Actually we are looking at the different types of the stresses. First we have seen what is meant by the tensile load and tensile stress, tensile strain, what is meant by the compressive stress, compressive loading and compressive strain, how mathematically stress is expressed, how mathematically strain is expressed, what happens in case of tensile loading regarding the change in dimensions, what happens in case of the compressive loading in regarding the change in dimensions of the body. So in coming lectures we will see what are the different types of the stresses, that is the shear stress, bearing stress, bearing pressure, bending stress, etc. I hope you have understood what is meant by the concept of stress, what is meant by the concept of stress, strain, what is the concept of tensile stress, what is meant by the tensile strain, what is meant by compressive stress, what is meant by compressive strain. Thank you.